Okay, so this is recording, I hope. Um, the question here is for tutorial 8, extra example, problem, answer, final answer. Why is Q surrounding negative? Is it because surrounding is losing heat? This affects the estrogen value. So, okay, let's look at the example. Uh, tutorial 8, extra example. Good, good. And so let's go down. So we have Q surrounding. Ooh, Q surrounding is indeed negative. It is negative 129.9. So where is it calculating? It's calculating it right over here. That Q from state 1 to state 2 is using this formula. He made these assumptions, tank is stationary, blah blah blah, energy balance to this, there's no work, and delta E, he used MU and the different masses, MA, MB, and he got this. So why is this not negative? Let's go up and try to understand the question itself, what it's saying. The question says that we have two rigid tanks, both are filled. Tank A has this stuff, tank B has this stuff. Good thing. Now we have what's happening is that they both are connected and there's a valve which initially is closed and then we open it. After opening, it says what's happening is that we have a reservoir at 300 degrees Celsius and we transfer enough heat from the reservoir um, at 300 degrees to have the final pressure. So state 2, we have this pressure. Good. But in order to understand what's happening here, we need to understand what direction the heat transfer is happening in. So it says that the reservoir is at 300 degrees and we transfer enough heat. So heat is being transferred from the reservoir into the tanks. So heat is being transferred from the heat source, which is at 300 degrees Celsius. It should say here, schematic is incomplete. I guess the TA should be deduct marks over here, incomplete schematic. However, heat source is at 300 degrees Celsius. It's going into these tanks. So if we just look at the heat source and we analyze what's happening there, and we find the Q, we would say that heat source is losing heat to the tanks. So the Q, whatever the quantity it is, it would be negative. But it is really important to understand that if our system is the tanks and we solve for Q, then Q is Q in, and Q in and the negative positive values for Q or Q out, those are all notations and different methods to actually identify and give direction to the magnitude of heat transfer. So Q, any number we get would be a magnitude, but how do we define the direction of it? There are different ways. Number one is you just say it's Q in, Q out. That's the simplest way. But in a lot of the examples in textbooks and even this tutorial example, it doesn't say Q in, Q out. It says Q and that's it. And we have to establish positive and negative ourselves given what we're studying. So when he's solving it over uh, here, um, we take this as a system and okay, over here, when he's applying the energy balance and he's actually solving for Q, what he's doing, he's taking his tanks as a system. So over here we have Q in from state 1 to state 2, we have Q in. So Q in would obviously be positive. So either he can write Q in or he can write Q as a positive number. But once he is doing the total S gen, he's include in his study of the system, he defined this definition of the system, this definition of the system is different. That's why the Q is positive here and it's negative here because over here he's taking into account the surroundings. So the surroundings losing heat and Q surrounding has a direct impact on Sgen because it's in the formula. So if Q surrounding is negative, given this system, that Q is being lost by the surroundings to the tanks, it's negative. If we were just gonna be studying this system over here, then Q is obviously positive because Q in. Over here, there's Q out. From the source, heat source, we're applying it to the heat source, so Q surroundings. If surroundings mean that we're studying the heat source, the surroundings, we're not studying the tank itself. But Q1 to 2, this means that we're studying the tanks, not the surroundings. But in SGen formula, we have Q surrounding, not Q1 to 2. We don't care about Q1 to 2. In order to use this formula for SGen, we need Q surrounding, which is negative of Q1 or 2, because the magnitude of heat being transferred does not change. The magnitude is fixed, that we're transferring this much, but in what direction? It depends on what are you studying. If you're studying this, it's Q in. If you're studying the surroundings, it's Q out. And when it's Q out, it's a negative Q right over here. I hope that explains it. It does have an impact of SGen directly. Let me see if there's anything else which is unanswered. Second, we have applied a lot of equations. That's right. When do we have to apply the Briggs equation? Briggs equation, honestly, I don't know. I haven't come across a question yet, but I cannot say. I will. How do I pause? Stop.